Okay, so this is going to be a set of videos on inverse trig functions. If the idea of an inverse function is that if I have a function f of x is equal to y, and it's what we call one-to-one and onto. Now I'm not going to get a lot of, not going to get into those specific terms right now, but it just means that the function is invertible. Then there exists a inverse function where if I take f inverse of y, I get x back. So like the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of a square is a square root. These kind of things are inverse functions. The trig functions also have inverses, but I have to make some restrictions. F of x is equal to the sine of x is only going to have an inverse if I restrict x from negative pi over 2 to pi over 2. Okay, so this means I'm going to restrict it to quadrants 4 and quadrants 1. F of x is equal to cosine of x will only have an inverse when I restrict x from 0 to pi. So this is going to be only in quadrants 1 and 2. And the tangent will have an inverse like the sine from negative pi over 2 to pi over 2. And that's going to be restricted there. And that's again in quadrants 1 and 4. Note the tangent is a little bit different because we don't get equivalence here. And that's because the tangent doesn't exist at negative pi over 2 or pi over 2 because you get division by 0 there. So if I restrict this way, I get a sine inverse of x, which is going to be restricted from negative 1 to 1, because negative 1 is the minimum value that the sine can take, and 1 is its maximum value. Similarly, I get a cosine inverse of x, which is also restricted from negative 1 to 1. And I get a tangent inverse. And again, the tangent's a little weird here because this actually exists from negative infinity to infinity, or in other words, for all real numbers, because the tangent does not have an upper or lower bound. Okay, so in some textbooks you'll see this as the arc sine, the arc cosine, or the arc tangent. These are just other words for the inverses of these functions. Alright, so let's take a look at this a little bit deeper. Okay, so let's look at the sine inverse of root 2 over 2. And if you look in the first or fourth quadrants, the only place where this actually happens is at pi over 4. So that's how we find the sine inverse there using our unit circle. But let's take a look at the sine inverse of negative 1/2. Okay, so if you look at the unit circle in quadrants 1 and 4, that's going to say it's at 11 pi over 6. But you have to remember that we're restricting x from negative pi over 2 to pi over 2. So this value is not on that range. So what I have to do is I have to look for a value that's on that range, and that would require me to go clockwise to negative pi over 6 is actually going to be the sine inverse of negative 1/2. Okay, because that's the value of sine. That's where sine is equal to negative 1/2 on this domain. Okay, so let's look at the cosine inverse. So let's say I have the cosine inverse of negative root 3 over 2. Okay, so remember the cosine is in the first and the second quadrant, and the place where that happens is at 5 pi over 6. You can check that on your unit circle. And if I look for the tangent inverse, tangent's a little bit trickier because you have to do some division of like the square root of 3. And remember, this is also in quadrants 1 and 4. the place where the inverse tangent is, or the tangent is equal to the square root of 3 in quadrants 1 and 4 is at pi over 3. Alright, so there you go. This is an introduction to inverse trig functions, and we'll do some more work with this in class tomorrow.